All right, let's look at an example. We'll just do a transverse wave example. If you can analyze a transverse wave, the longitudinal waves are not really overly complicated. So here I've got some rope. We'll say that someone's kind of shaking and causing these waves from crest to trough. It's 8 centimeters, and the whole length of this rope is 3 meters. And using this terminology, we want to figure out what's the amplitude of this wave and what is the wavelength so we can kind of analyze this wave further. So to find the amplitude, we just have to recognize that 8 centimeters is from crest to trough, right? So this is a crest up here. This is a trough down here. And that's 8 centimeters. Well, one amplitude is from a crest to equilibrium or from the equilibrium to the trough. So the 8 centimeters is in fact 2 amplitudes, so we just cut that in half. So it's 4 centimeters up to a crest or 4 centimeters down to a trough. That is the amplitude. Going from a crest to a trough is actually double the amplitude. So 4 centimeters is the amplitude of this wave. To get the wavelength, we have to realize that we have a total length of 3 meters. And I tried to show on here, we actually have 3 full waves. Okay, if I start from this point here, that's like an upward sloping point on the equilibrium. This over here is the next upward sloping portion. Same here and same here. So we actually have 3 full waves. We've got wave 1, wave 2, and wave 3. So if I have a total length of 3 meters and there's 3 full waves on that, that means that each one has to have a wavelength of 1 meter. And that's one of the ways we can kind of apply this. So we'll have more practice with this, but understand this terminology, understand how we use it, and you'll find that waves and repeated motion becomes quite a bit easier to actually analyze.